When I get to the right page, there we go. So, we've been talking about quadrilaterals this whole chapter, right? So, a quadrilateral is what? A polygon with four sides, right? Then we went into special quadrilaterals, starting with parallelograms. We talked about all the properties of parallelograms. And then we learned about special parallelograms called rectangles, rhombuses, and squares. And they all have different properties as well. So we've discussed all of those. So today we're going to talk about another quadrilateral called a trapezoid. Now, a trapezoid is not a parallelogram because it only has two sides that are parallel. So a trapezoid is just a quadrilateral. It's not a parallelogram, even though it does have two sides that are parallel. The two that are parallel are called the base, and they make base angles. So the two base angles would be the ones where the base connects to the legs, okay? The sides that are not parallel are called the legs. If the legs are congruent, then you have what is called an isosceles trapezoid. And we will do some properties with isosceles trapezoids here in a minute. So here's some more theorems about trapezoids. And these are isosceles trapezoids. So I'm going to let you draw and write these down before I talk about them. All right. So it says if a trapezoid is isosceles, that means we know the two legs are congruent measures, then each pair of base angles are congruent. So we have two pair of base angles. All right, for a trapezoid, it's where the legs meet the bases. And the bases, remember, are the parallel segments. Okay? So if we have a isosceles trapezoid, then we know, for instance, that these two base angles are congruent and the two at the top are also congruent. Okay? So that is that theorem. The next theorem says if we have one pair of congruent base angles, then it's isosceles. So if you know one pair of angles, of base angles is congruent on a trapezoid, then it must be that these segments are congruent also. Okay, so that's how that one is worded. All right, one more, then we're going to start seeing some examples. So this one has to do with the diagonals of the trapezoid. Remember that diagonals connect the opposite angles of a quadrilateral. So if the diagonals are congruent, then you have an isosceles trapezoid. And if you have an isosceles trapezoid, then the diagonals are congruent. So that if and only if there means it goes that statement and the converse is true. If we have an isosceles trapezoid, then diagonals are congruent. If we have a quadrilateral with diagonals are congruent, then it's an isosceles trapezoid. If it's a trapezoid, it could be a rectangle. But if it's a trapezoid, then that's the case. So not all trapezoids are isosceles trapezoids. Okay, they don't have to have these two legs congruent, but if they are isosceles trapezoid. So if they tell you it's isosceles, then you know both pairs of base angles are congruent. If they don't show you or tell you it's isosceles, you don't necessarily know that. All right. If you open your book to page 543, I'm not going to make you do that, but if you do that, there is a picture of a stone archway. Okay? There is a picture of a stone archway around a door. And at the top of it, the bricks look like this. This is a picture of a brick in a stone rounded archway. Okay? And it tells you the stone above the arch in the diagram is an isosceles trapezoid. So it tells you this trapezoid is isosceles. JM is parallel to KL because those have the parallel line markers. All right. So, and it also goes ahead and shows you that KJ is congruent to LM. So the legs are congruent, making it isosceles. They want you to find all of the other angle measures. They show you in the picture that the measure of angle L is 85 degrees. Right? So if this is an isosceles trapezoid, and it is, do I know another angle measure? Yes. Which one do I know? It's K. Okay, it's not a parallelogram, so it's not the opposite one. It's the one that's the base angle with it. The base angle touches the leg with it. Okay, touches the legs. So if I know L is 85 degrees, then the measure of angle K is also 85 degrees. So this one's also 85 degrees. Now we've got to find the measure of J and M. And they are going to be congruent to each other, aren't they? Because they are also base angles of an isosceles trapezoid. But how do you think we're going to find that measure? What kind of lines are these? Parallel lines, right? So if I were to extend those lines and see that they're parallel lines, then this would be a transversal. LM would be a transversal, would it not? So if LM is a transversal, what is L and M's those angle relationships to each other? Consecutive interior angles, right? And what do we know about consecutive interior angles? They're supplementary, right? They make a linear pair. They're 180 degrees. So if I want to find the measure of angle M, I would say 180 minus 85. How much? 95 degrees. And if the measure of angle M is 95 degrees, what's the measure of angle J? 95 degrees. Because they are base angles with each other. And base angles are congruent in an isosceles triangle. Now, all together, since it's a quadrilateral, the interior has to be 360. Would that be 360? Yeah, because I would have 180 plus 180 makes 360. So any questions about how we got those angle measures? The base angles will be congruent, and the consecutive interior will be supplementary. Okay. All right. Let's talk about mid-segments for a second. I'm going to hush and let you write. I wouldn't think you would need to draw this picture. Second. I don't think it's beneficial. You can mark what you need to mark on one picture. All right, so let's talk about a mid-segment. A mid-segment is a segment of a trapezoid that goes through the middle that connects the midpoints of the two legs. Okay, so since it's connecting the midpoints of the legs, from here to the mid-segment is congruent with from here to the top of the base. Same thing with the other side. So it's connecting the two midpoints of both sides so that you know you have two sets of congruent segments. All right? Something else you need to know about a mid-segment is that it is parallel with the two bases. So if you just want to put a parallel mark right here with the first picture and put the all three parallel on that picture, that might save you some drawing time. I don't know if you can see mine, but I'm really thin. I'll make them bolder. Okay? So all three of those, the legs, the bases and the mid-segment of the trapezoid are all three going to be parallel with each other. Okay? You need to memorize this formula. The length of the mid-segment is 1/2 of the sum of the two bases. You don't necessarily have to memorize those letters. I don't have enough room. Memorize it like this. Mid-segment length equals 1/2 of the length of both bases added together. Does that make sense? So you're going to take this length and add it together, and then half that number, and that tells you the length of the mid-segment. So another way to say that is it's also the average of these two lengths. So it's exactly in the middle, the average of these two lengths. So you take the two bases, add them together, and multiply by 1/2. Multiplying by 1/2 is the same thing as dividing by 2. Right. So that makes more sense when we see it in an actual problem. And I left my work on there, and I did not mean to. Thought I erased all of them, but I guess I didn't. So I'll freeze y'all out for a second. There we go. All right, draw this trapezoid. They tell me that MN, which is the blue segment, is the mid-segment of the trapezoid. Find the length of MN. So if they didn't tell me it was the mid-segment, would I know it was the mid-segment? Yes. How would I know that it was? These two are congruent, and Q, N, and N are also congruent. So that way I know I'm connecting my two midpoints. Okay, so even if they wouldn't have told me it was the mid-segment, I can look at the picture and tell that it is, just by the congruence marks. All right, so what you're going to do to find the length of MN? Oh, right, wrong thing. You're going to say 1/2 of base plus base. So what is the length of the base of the base PQ? 12. And what's the length of base SR? 28. Now, order of operations, we do parentheses before we multiply, correct? Okay. So what is 12 plus 28? 40. And what's half of 40? 20. And these are in inches, so your answer needs to be in inches. The length of MN equals 20 inches. Now, y'all, see if that makes sense. How many places away from 20 is 12? It's 8 numbers away, right? 8 integers, I guess. And same thing from 20 to 28, right? That should be that. The length of the mid-segment should be halfway between the lengths on either side. It should make sense like that. All right, here's another one. This time, though, you are not finding the length of the mid-segment. They gave you the length of the mid-segment. This time, you're finding the length of one of the bases, ML. How do you think you do that? How are we going to set it up to find it? Well, we use the formula mid-segment equals 1/2 base plus base, right? And since we know the length of the mid-segment, we could say 12 equals 1/2 of base plus base, right? One base is 9, and the other base is x. Okay, y'all with me? Now we got to solve for x. Algebra 1 stuff coming on through here. If I want to get rid of that 1/2, what do I need to do to both sides? I don't want to distribute this one. Dividing by 1/2 is the reciprocal of 1/2, which is what? 2. Yeah. Multiply by the reciprocal on both sides. What's 2 times 12? So 24 equals 9 plus x. And how do I solve for x? Subtract 9 on both sides. And 24 minus 9 is 15. Does that answer make sense? Is 12 halfway between 9 and 15? Yeah. It didn't give me any units. Oh, it did, didn't it? Centimeters. Make sure to use your units if they give you units. So if you're looking for one of the bases, you set it up. Mid-segment equals 1/2 of base plus base. All right? And then you multiply by 2 on the other side to get rid of your 1/2. And then you subtract the other base. Okay? All right? Same setup here. Oh, we just did those same numbers, didn't we? Not doing it. Nah, not doing it. Refuse.
15 and 30.
Shush. Okay, here we go. So remember, it's mid-segment equals 1/2 of base plus base. So the mid-segment here is what? Equals 1/2 of 40 plus x. How do I get rid of 1/2? Which is 2 on both sides. What's 2 times 53? 106 equals 40 plus x. And then what do I do? What do I get? 66. Didn't give me any units that time, did they? So there we go. Any questions about that? Is 53 halfway between 40 and 66? I want you guys to try those two. On number 1, you're finding the mid-segment. On number 2, you're finding one of the bases. So y'all try those two. You know if you need help. All right. So on number 1, are you looking for the mid-segment or the base?
The big step.
Mid-segment. So x is going to equal what? A half times
19
plus 31. What is 19 plus 31? So what's half of 50? And that one didn't have units. So raise your hand if you got x equals 25 for number 1. Are there any questions? All right, number 2, are you looking for a mid-segment or a base? You're looking for a base. So you're going to do mid-segment equals 1/2 of base plus base again. So what was the mid-segment's length? 10 equals 1/2 of, what are your bases? Or x plus 14, either way. And then what do you do first on this one? Multiply by 2 on each side. So that's 2 times 10 is what? 20 equals x plus 14, or 14 plus x, either one. So you have to subtract 14, and what do you get? 6. Does that make sense? Is 10 halfway between 6 and 14? So you can always look and make sure your answer makes sense. So raise your hand if you got 6 for number 2. Very good. All right, so I do want to show you one that is like a homework problem with some decimals and different variables. So y'all look at this problem. You might want to write it down because this is number 27, and I think you've got 1 or 2 like it on your homework. So we'll work this one together. Or if we talk, I just won't. Okay, so we're going to use the same formula. Mid-segment equals 1/2 of base plus base. So make sure you plug everything in the right spot. What goes in for the mid-segment? 18.7 equals 1/2 times, what are my lengths of my bases? Okay. Now there's one thing I can simplify before I get rid of my 1/2. What is it? Yeah, these are like terms, aren't they? Right? So we're doing a little algebra 1 today. What is 5x plus 12x? 17x minus 1.7. Now I really don't want to distribute that 1/2. So how do I get rid of it? Multiply by 2 on both sides. And we can use our calculators to help us. So I want participation, please, and y'all tell me what 2 times 18.7 is. 37.4 equals 17x minus 1.7. Now we just got to solve it for x. So how are we going to do that now? Add 1.7. What do we get? 39.1 equals 17x. And then we do what? Divide by 17. What do we get? 2.3. And they didn't give me any units on this one, so you don't have to tell me units. But if they do give you units, you need to tell me what they are. So that's as rough as it's going to get. So does everybody understand how we did that? You just simplify it just like it's Algebra 1. All right, so we're going to stop here for the day. That's the end of section 8.5. Quiz tomorrow. Have a good day.